Okay, so I'm just going to go over this first one again real quick. So I'm actually recording now. The first one you're supposed to multiply, kind of multiply top and bottom. Okay, so you're going to multiply top and bottom by here x plus, or x minus 2, right? And here x plus 5.
What's wrong?
Is it working? Oh, well, because I can't write horizontally. So. Okay, so then you can kind of already see the answer here. But you're actually multiplying top and bottom by x minus 2 and x minus 5, x plus 5 on this one, right? Okay, so you can see that there's a 1x and a 2x, that's 3x, and there's a minus 2 and a plus 10, so there's your 8. So that's pretty easy. Doesn't take any critical thinking to do that. But this kind of shows it, doesn't it? So without further ado, on this one we're saying we don't know what goes here, and we don't know what goes here, but we'd assume that the two linear factors would go down here. So basically x minus 5, right? This would be your x plus 1.
I think you need to recalibrate.
Yeah. Okay.
Well, yeah, just like watch you write something on there real quick.
All right, so it really is two equations is the trick here. So after recombining, this is x plus 1. Multiplying this by x plus 1, multiplying this by x minus 5. You have basically 5x minus 31. And this side you have ax plus bx plus a minus 5b. But now the denominators are the same. Right? So we turn this into a system of equations. Basically, you have 5x is equal to ax plus bx. So 5x is equal to ax plus bx. And then you have negative 31 is equal to a minus 5b. It really is two equations. So can you see why I waited until this time in the chapter to teach this to you? It's kind of a new topic in a way, but it sort of becomes just a system of equations. So if you hadn't studied systems, you might actually get stuck here. But this is a pretty easy problem, right? I would just subtract the equations. Did anyone do that? This gives me 6b equals 36. And then since a plus b is 5, I can write a plus b equals 5. So you can see that a is basically negative 1. Okay, please make sure that you finish this problem by writing 5x minus 31 over x squared minus 4x minus 5 is equal to, and then negative 1 over x minus 5 plus 6 over x plus 1. In other words, you decompose the fraction. You decompose the fractions. I actually did that here, see? But you need to write the answer as if it's like a conclusion, right? So don't just kind of stop when you get A and B. Go ahead and write your answers like this. Make them look nice. Does that make sense? So please do that. Just make it look nice by writing the original composed fraction and the decomposed partial fractions. These guys are called partial fractions. Okay, so let's try something else now. What I'd like you to do is just make up any two fractions like this, add them together, and then give it to your neighbor and see if they can figure out what two fractions you've added. Let me give you some ground rules for this though first, because this can be too hard. You can actually make it way too hard for that. For this class, I suggest we just start with simple stuff on the bottom, okay? So maybe an x plus 1 and maybe a 3x plus 5 is fine, okay? But don't put anything quadratic downstairs. It really does change everything. So just nice linears on the bottom there. And then if you want to be a little bit mean for the numerators, you can put like half and -3/5 or something. That's a little cruel. They're going to have a hard time unraveling it. So maybe use whole numbers here, like make this -2, and maybe make this 4 or something. But then secretly just kind of recombine it. So multiply this up here, multiply this up here. It's your choice if you want to FOIL the denominator and make them factor it. But basically, you would give them the problem like this. Or you can leave the bottom factored if you're a nice person. And they have to figure out how you got that. Okay? So they're going to have to factor it, make an AB fraction, recompose it, write down system, solve A and B. When you're done, and they're done solving your problem, then have them write a problem and switch. Why don't we just have everybody write a problem, then we can do a quicker trade when we get halfway through this. So just take 2 minutes, write a question, hand it off to your neighbor, see if they can solve it, and then the neighbor will hand you theirs. You can solve them simultaneously. All right, ready to go? You cannot play this game alone. This is one of those games. It doesn't work alone. Because you already know the answer. Let me explain real quickly why I'm teaching you this. Okay, for one thing, it does have to do with systems. But here's another reason, a better reason. If you take my BC Calculus class next year, you will see problems like this. Okay, you might not know what this means yet, but you might see a problem like this next year. And this problem is very challenging at first glance. But actually, if you rewrite it like this, this is the warm-up problem. So if you rewrite this problem as, what were the two answers for this one? If you write the problem like this, you realize this is actually two very simple problems. It's this one and this one. So now I know you guys probably don't even know what this is yet, but understand this. The fact that this problem was written like this was what made it hard. But after rewriting the problem like this, it's very easy. It's actually two very simple problems. If you gave this to a calc student, they'd have them done in 10 seconds, both of them. They're very, 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 very easy now. Okay? So partial fraction decomposition is a way of rewriting a fraction in a more friendly way to make the problem simpler. Does that make sense? Okay, so even if you don't know what this is about, you can see how it would help us get through the problem anyway. All right, here comes your last page of the exam. You can keep your note cards out, but no.